It's my pleasure to be here and to be a part in this event. So for this, I owe my gratitude to Open Power and Sastra University for providing me such a wonderful opportunity. So to introduce myself, I'm Sri Kamani, working as a tech lead in Object Automation Software Solutions, Pvt. Ltd, a leading AI organization in Chennai. In today's session, actually, I'm dividing the session into two sections. Once the first session, I'll be covering up all the theoretical part of the basics of machine learning. So how a student, as you all a student, how you can develop your machine learning knowledge. So for that, I'll be covering up the basics of machine learning. And the second part will be how to deploy your machine learning algorithms in your HPC servers. So what you have in your universities. So these are the two sections I'll be covering up today. So in the first session, I'll be covering up what is the basics of machine learning. That is an overview of machine learning. And what are the algorithms you have in your machine learning and the use cases and its applications. So with further delay, we'll move on to the session. So the agenda of today's session will be, first I'm just going to explain what is machine learning. And the next topic will be the difference between what a traditional programming is and what is machine learning. Then I'm just going to give you a detailed demo introduction about how does machine learning work. And then what are all the algorithms you have to learn in your machine learning development. And then the use cases in machine learning. And then how to choose machine learning algorithm. Suppose if you are going to work with a problem, how you have to choose your machine learning algorithm. So that in that case, you have to very much clear about that. So, and then we'll be learning about the challenges and limitations of machine learning, and then the applications of machine learning. That is, in what are all the sectors, what are the areas we are applying this machine learning techniques. And the last is, why is machine learning important? That is, what is the need for you to study about machine learning. So these are the sections we are going to learn in this, we are going to cover in this session. So going to start with what is machine learning. So before getting into what machine learning is, we should have a clear idea about what artificial intelligence and that is the difference between artificial intelligence and machine learning. So what is artificial intelligence? So artificial intelligence is a concept of creating intelligent machines that stimulates human behavior. So whereas machine learning is a subset of artificial intelligence that allow machines to learn from data without being programmed. So machine learning will be programmed in such a way that systems will learn from your data. So with the definition of Tom Mitchell, we can say machine learning is a study of algorithms that improve their performance P at some task T with experience E. So a well-defined learning task is given by Pte. P is nothing but your performance, T is your task, and E is your experience. Experience is nothing but your data. Okay. So machine learning application is an AI that involves algorithm and data that automatically analyze and make decision by itself without human intervention. So it describes how computer perform tasks on their own by previous experiences. So therefore, we can say in machine learning, artificial intelligence is generated on the basis of experience, that is on the basis of data. So for this, we have one good example. So one possible application of machine learning model would be to predict how likely a customer is to purchase a particular product based on their past behavior. That is based on the behavior of the customer. That is based on the items purchased by a customer. The data is what you have about your customers. Based on that, you can give a prediction that how likely a customer is going to purchase a particular product or not. So in this way, we can use machine learning. So the next thing is, what is the difference between a traditional programming and machine learning? So you are all, I think, since you are all from MCAs, computer science department, you know what traditional programming is, right? You would have learned about programming in C, Java and all. So what is normal traditional programming? So traditional programming is a manual process. It means meaning a person creating the program. So what we have the input data, and someone like a programmer or developer, they have to code a program that uses the data and runs the program on a computer to produce your desired output. So your input will be, your program will be based on your input and output. So you have to write your own coding to get that output. So what we are going to do on machine learning. So on the other hand, in machine learning, the input and output are fed into an algorithm. It's a common algorithm. So to create a program. So the algorithms that automatically formulate the rules. So you know what an algorithm is, right? Any idea about the algorithm? This is the basic what you have learned in your maths and science. So that will be your algorithms, right? So the input data and output are fed into an algorithm to create a program. These algorithms automatically frame the rules for the data, which is powerful for your prediction. Okay, so this is how a machine learning work with the difference of normal programming language. Okay. And if you are a basic learner, that is, if I'm having an interest to work with machine learning, to learn machine learning, then how I have to start with this learning approach. So this is the steps. This is the 7 basic steps you need to follow when you start learning or coding your machine learning algorithms. So the first step will be the objective definition. So what is objective definition? It is nothing but your problem statement identification. So before getting into your work, you have to very much know, well versed with your problem statement. So what is the problem? You have to identify what is the problem. So that is a basic step in your development. So once the problem is stated, so given the problem you want to solve, you will have to investigate and obtain data. So that will be the second step. That is the data collection step. So you have to go for investigation and obtain the data that you will use to feed your machine. So here the quality and the quantity of information, that is the data you get, are very important, since it will directly impact how well or badly your model will work. So if your data is perfect, means you will get a perfect accuracy in your model. If you have some variations in your data, means then it will create a problem in your model creation. So data is a very big component in your data model creation. So you may have the information in an existing database. If you are going to collect data from your from a domain or from a firm, so already you may have they may have a data as a database, as a Excel sheet or somewhat like that. If you have that data, you can use that. If not, so you have to create a data set from scratch. Okay. So this is the basic approach to create a data set. Either you can use a spreadsheet that will later can be easily exported to a CSV file, because most of the machine learning approach we will use CSV file as a data set. Then it is also common to use web scraping technique to automatically collect information from various sources such as APIs. So this is another advanced technique, web scraping technique, where you can collect data from your web resources. Okay. So once data is collected, you have to go for data preparation. So what is data preparation? As I mentioned here, it is a crucial part in your machine learning approach. Okay. So this is the time where you have to go for data visualization. So what is data visualization? Why we are going for data visualization? So after doing your visualization technique, you can go for data cleansing. What is data cleansing? It is used to remove your duplicates in your data set. If you have any duplicate values in your data set, you have to go remove that. And if you have any errors in your data set, you have to go correct that, and you have to deal with missing values, and you have to do normalization and data type conversions. So all these things you have to do it in your data preparations. And after that, you need to check if there are correlations between the different characteristics that you obtained. So it will be necessary to make a selection of characteristics, since the ones you choose will directly impact the execution times and the results. So you can also reduce the dimension of your data set by applying PCA technique if necessary. So additionally, you must balance the amount of data we have for each result or class so that it is significant, as the learning may be biased towards a type of response if your data is not balanced. So once data is prepared, once all the data, whatever the data you have collected is good for your next approach, the next step you have to do is you have to split your data set into two parts, one for training and one for evaluation. That is your testing part. Okay. So once the data set is ready, you have to go for algorithm selection. So that will be a fourth step in your machine learning work. So what is algorithm selection? So we have various algorithms available to be used depending on the data you are going to process. So we have different features like data types in your data set, like images, it can be a sound, it can be a text, or numerical values, and so on. So based on your problem statement and about your applications and with your data set, we have to go with the applications like whether it is a prediction or a fraud detection or image so on and so forth. So based on these applications, you have to go select your algorithms. We have several variety of algorithms available for machine learning techniques. So based on your data set and your problem statement, you have to go select your algorithms. So the next step, once the algorithm is selected, you have to go for the model training. So what is model training? You will need to train the data set to run smoothly and see an incremental improvement in the approach. So this is the model training. You have to feed in your data set to your algorithm. Okay. So once data is fed into your algorithm, your model, you have to train the model. Remember, we have to initialize the weights of your model randomly. So what are weights? The weights are the values that multiply or affect the relationship between the inputs and the outputs. One second. Okay. So what are the weights? The weights are the values that multiply or affect the relationship between the inputs and outputs, which will be automatically adjusted by the selected algorithms the more you train them. Okay. So once the model is trained, you have to go for the testing. That is, you have to evaluate the model. So you will have to check the model created against your evaluation data set. So what is your evaluation data set? So when you are preparing your data set, I have told you that you have to split your data into two formats. One is for training and another is for testing. So that testing set data set you have to include in your evaluation format. So that evaluation set contains inputs that the model does not know about and verify the precision of your already trained algorithms. Okay. So if the accuracy is less than or equal to 50%, that model will not be useful, since it would be like tossing a coin to make decisions. Suppose if you reach 90% or more of your accuracy, you have a good confidence in the result that the model gives you. What the result the model gives you will be in a good confident level. So if during the evaluation, if you did not obtain good predictions and your precision is not the minimum desired, it is possible that you have overfitting or underfitting problems, and you must return to the training step before making a new configuration of parameters in your model. So what you have to do is you can increase the number of times you iterate your training data. That is, we called it as epochs. And another important parameter is one known as the learning rate. So which is usually a value that multiplies the gradient to gradually bring it closer to the global or local minimum to minimize the cost of the function. So like increasing your values by 0.1 units from 0.001 is not the same as this can significantly affect the model execution time. So you can also indicate the maximum error allowed for your model. That is, you can go for taking a few minutes to hours and even days to train your machines. So these parameters, which helps for all your uplifting of your model, are called hyperparameters. So the tuning is still more an art than a science. This hyperparameter tuning is still more of an art than a science, and it will improve as you experiment. So there are usually many parameters to adjust, and when combined, they can trigger all your options. So each algorithm has its own parameters to adjust. So the hyperparameters will differ from algorithm to algorithm. So each algorithm has its own parameters to adjust. This will be a work of great effort and patience to give good results. So you have to put great effort, and you need much more patience to get your better results. Okay. So once for all the testing and training is done with a good accuracy, now you are ready to use your machine learning model inferencing result in for your real life scenarios. So what is that? It is called integrating your model. So machine learning model inferencing, how you can integrate your machine learning model. Either you can publish your model as a web service or as an application. So in this way, you can integrate your model for your real life scenarios. Okay, so these are the 7 basic steps you need to follow when you are going to start working with your machine learning techniques. And next is about your machine learning algorithms, the basic details about your machine learning algorithms. So if you are going to start learning about machine learning techniques, what are the algorithms, what are the approaches you have to do? So we have 3 types of approaches. One is supervised learning, another one is unsupervised learning, and the third one is reinforcement learning. So these are the 3 types of approaches you have in machine learning techniques. So what is supervised learning? So in supervised learning, the machine is taught by example. That means the operator provides the machine learning algorithm with a known data set that includes desired inputs and outputs. So, and the algorithm must find a method, that is, should find a pattern to determine how to arrive at those inputs and outputs. So while the operator knows the correct answer to the problem, the algorithm identifies patterns in data and then learns from the observations and makes predictions. So the algorithm makes predictions and is corrected by the operator, and this process continues until the algorithm achieves a higher level of accuracy or performance. Okay, so this is called supervised learning. So in supervised learning, you have 2 methods. One is for classification and another one is for regression. So in classification, in regression, what are all the models you can work is? Sorry. So you can go for forecasting, predictions, process optimization, and new insights. And if you are going for classification methods, you can go do fraud detection, that is like credit card fraud detection, like that. And image classification, using your classifications algorithm, you can do fraud detection, image classification, then customer retention, and your healthcare diagnostics like cancer detection or diabetic detection, like that. And if you are going to work with unsupervised learning method, so what is unsupervised learning method? So in unsupervised learning, the machine learning algorithm studies data to identify patterns. So we won't provide any answer key or human operator to provide instructions. So instead, the machine determines the correlations and relationship by analyzing with the available data. So in an unsupervised learning process, the machine learning algorithm is left to interpret large data sets and address that data accordingly. So the algorithm tries to organize that data in some way to describe its structures. So what do you mean by structure? It is nothing but you're grouping the data into clusters or arranging it in a way that looks more organized. So if you are going with unsupervised learning approach, there are 2 possibilities you can do. One is clustering and another one is dimensional reduction. So if you go for clustering method, you can do recommended systems, targeted marketing, and customer segmentation. If you want to go for dimensional reduction, you can work with big data visualization, then meaningful compression, then structure discovery, and future illustration. Then the third one is the reinforcement learning. So what is reinforcement learning? So the reinforcement learning method focuses on a regimented learning process. So here a machine learning algorithm is provided with a set of actions, parameters, and end values. So by defining the rules, the machine learning algorithm then tries to explore different options and possibilities, monitoring and evaluating each result to determine which one is optimal. So in reinforcement learning method, it teaches the machine the trial and error possibilities. So it learns from past experience and begins to adapt its approach in response to the situation to achieve the best possible result. So in reinforcement learning method, we can go for robot navigation, skill acquisition, then learning tasks, then gaming, and then real-time decisions, and even the driverless cars. Everything comes under this reinforcement learning method. So this is all about the approaches of machine learning. And the next thing is about your algorithms. What are the different algorithms available in each learning methods? Okay, so we have, as I said, we have three types of learning method. One is supervised learning, another one is unsupervised learning, and the third one is reinforcement learning. And if you are going to take with supervised learning method based on your data set, that is, if your data are in a continuous values, if you have continuous value data set, you can go with regression algorithms. So you can either with, if you are going with regression model, you can go choose either linear regression algorithms or polynomial algorithms or decision tree or random forest algorithms. Suppose if your data set have categorical values, in that case, you have to switch to classification method. So in classification, we have the basic algorithms like KNN and even the trees, that is the decision trees and random forest. And we have logistic regression and navy Bayes and support vector machine algorithms. And if you are going to work with unsupervised unsupervised approach, so if you are working with continuous data set, you can go for clustering. So in clustering, you can go with SVD algorithms, PCA, and K-means clustering. If you have categorical values in your data set, you can go with associations and hidden Markov rules. So these are the various algorithms available. Based on this available algorithms and your data set, you can go for based on your problem set, you can select the algorithm and you can do your prediction details. And the next thing is about the use cases. So how you can use this machine learning, that is, what are the various sectors this machine learning techniques can be applied. So if you want to go with your projects, you can select one of these areas and you can do your projects. So what are the various sectors available for to deploy this machine learning techniques? You can go with energy feedback utilities. So in energy feedback utilities, you can do this machine learning techniques for power usage analytics, systemic data processing, smart grid management, energy demand and supply optimization. If you want to go work with financial services, you can go take risk analytics and regulation, customer segmentation, and credit worthiness evaluation. If you want to go work with travel and hospitality sector, then in that case, you can go with aircraft scheduling, dynamic pricing, and traffic patterns and congestion management. And in manufacturing sector, you can go with predictive maintenance or condition monitoring, then demand forecasting, then process optimization and telematics. If you are going to choose with retail industry, then you can go with this. You can take this technique to predictive inventory planning, then recommendation engines and customer ROI and lifetime value. If you are going to work with healthcare, if you are going to develop a model in healthcare and life science industry, you can deploy this. You can develop models with alerts and diagnostics for real-time patient data. Then you can go with predictive health management and healthcare provider sentiment analysis. So these are the various sector you can do your projects as well. the main and the most important topic is how to choose an algorithm. I think this is a critical topic also, because there is no straightforward and short answer to this question. No single algorithm will solve all your machine learning problems better than other algorithms. So if you're a basic learner, you have to follow your algorithm cheat sheet, which is available in the internet. So you can follow the cheat sheet and you can go for your algorithm selection. If you want to find the answer depends on many factors like the problem statement and the kind of output you want, the type and size of the data, then the available computational time, then the number of features and observations in the data, and much more. So what I can say is there is no free lunch in machine learning. So determining which algorithm to use depend on many factors, many of these factors which I mentioned. So starting from the type of the problem at hand to the type of the output you are looking for. So to find a good model for a problem, so my suggestion is you may have to try different models and compare them using a robust cross-validation strategy. So this is how you can select a good algorithm for your problem statement. And the next thing is about the challenges and limitations you face in your machine learning techniques. If you are going to look about what are the advantages in this machine learning, we can say that it easily identifies the trends and patterns in your data, and then no human intervention is needed in its work. Then we can have continuous improvement. Then handling multi-dimensional and multi-variety data is easy, and we have a wide range of real-life applications like enhanced cybersecurity and spam detection, like that. So these are the main advantages of machine learning techniques. And moving on to disadvantages, that is the challenges you are facing in your machine learning. It's very difficult to identify and rectify the errors. So that is the first one, that is high error susceptibility. And the next challenge is about data acquisition. The collection of data is one of a very big challenge when you're going to start working with the machine learning techniques. So if you are a learner, you can have many websites where you can download your free data sets, but in your real life scenarios, data acquisition is a very big task. And then we have interpretation results, that is interpretation of results requires more time and space. And the next thing is time and resources. So it will be a bit time consuming task, and resources is a big challenge, but I won't say that we are in lack of resources. At present, we have several resources available to practice your machine learning models. So here in your colleges, I think they have created a very good infra to work with your ML techniques. So we have several types of servers from a variety of companies like IBM. They are providing AC922 servers and Dell X86 servers, and much more servers are there for your works. And apart from servers, we have other architectures also, advanced architectures also available for your work. So resources are available, but the challenge is a bit cost effective. That's it. So the next thing is about the applications of machine learning. That is, what are all the areas you can apply your machine learning techniques? Or what are all the areas we are currently using your machine learning techniques? The first one is automatic language translation. So what is automatic language translation? So the classic example for this is Google Translation. I think everyone would know about that, right? So Google Translation, in Google Translation, we can it can do translation between English and 100 other languages, I think. So it's not possible by a human being. And then it is medical diagnosis. So one application of machine learning in healthcare context is digital diagnosis. So what is digital diagnosis? It's nothing but ML can detect patterns of certain diseases within patient electronic healthcare records and inform the clinicians of any anomalies is found in their medical things like cancer detection or diabetes detection, like that. Okay. And you have stock market, you can apply this technique for stock price prediction and all. And if you go for online fraud detection, so online fraud detection, tracking monetary frauds online by making cyberspace as a secure place is an example of machine learning. So like credit card fraud detection and all. Okay. And then in virtual personal assistant. So virtual personal assistant, I think you all well know about that. Your smart speakers, smartphones, and apps like Google Hello, Alexa, Siri. These are some of the examples of virtual personal assistant where this ML technique is being used. Then we have email spam and malware filtering. So there are a number of approaches where clients use for this. So what these filters will do is these filters are continuously updated and powered, and these are powered by machine learning techniques. Okay. And then we have self-driving cars. So self-driving is driverless cars. Okay. So in this we are applying this reinforcement of this machine learning technique to make a car to move by itself. And then we have the product recommendation systems. What is product recommendation system? So all would have known about this online shopping and all. So in online shopping, while we search for a product, all its relevant products are displayed in our screen. So it is based on this technique of machine learning. And then we have traffic prediction. So what is traffic prediction? When you're going to use this Google map and all, they will predict your traffic things, right? So how is doing that? By using your GPS navigation service, it just out your locations are saved at the central server for managing traffic. So all your GPS locations are served on a server for managing traffic. So based on the number of GPS tracked at the location, traffic at the particular street is identified. So this is how traffic prediction is happening. And then you know about the speech recognition, all your Google things, Google Assistants and all. It's working under speech recognition technique. And even image recognition. Your driverless car is an example of this image recognition technique. Okay. So these are the applications of machine learning things. So apart from this, I'll show you some more applications where we are using this in real life scenarios. So for example, in financial services. So in financial services, we have robo-advisor. So this robo-advisor Wealthfront tracks account activity using AI capabilities to analyze and understand how account holders spend, invest, and make final decisions. So they can customize the advice they give to their customers. Okay. So this is how machine learning is deployed in financial services. And next is in insurance sector. So how machine learning is applied in insurance sector. So in auto insurance, customers can initiate claims through a mobile app. So just they click the pictures of the accident and submit the claims instantly. So what my algorithm will do is the algorithms that have been trained through pictures from past claims can accurately estimate the extent of damage and automate the claims and evaluation process. Okay, this is what my algorithm is doing in the insurance sector. And then in supply and chain operations, we are automating inbound quality inspections throughout logistic hubs. So we are inspecting, we are applying a machine learning technique for logistic inspection and isolating product shipments with damaged wear and tear. So we are just isolating the damaged products. So to isolate that, we are using this ML techniques. Okay. And then in retail industry. So how this ML is applied in retail industry? So in Japan's software SoftBank Telecom Operations partnered with a French robotic manufacturer called Aldebaran. They develop a humanoid robot called Pepper that can interact with customers and perceive human emotions. Okay, so this Pepper is already popular in Japan. This robot is already popular in Japan, where it is used as a customer service greeter and a representative in 140 SoftBank mobile stores. So it is proved that about 70% of the sales have been increased by this Pepper robot. Then the next sector is healthcare sector. So how this ML techniques are applied in the healthcare sector. So in Microsoft Hanover project in partnership with Oregon Health and Science University's Knight Cancer Institute. So they analyzes medical research to predict the most effective cancer drug treatment options for patients. So they are using this ML techniques to predict the drug. And the last one is the telecom industry. So how this ML is applied in telecom industries. Okay. So I think all would have heard about this chatbots, right? So now this many telecom companies have started using chatbots as a mechanism for front-end customer service. Okay. So these are the variety of areas where we are applying ML techniques. And in variety of ways we are applying this ML techniques. And the last and the important question is machine learning important, or why is machine learning important? Do you all think this machine learning is important? So why is it important? Let it be a different session. Instead of you questioning me, let me question you. Why is machine learning important? Why is machine learning important? To make your process? Okay, then time saving, then reduce your, okay, fine, then accuracy, okay, no need, yeah, no need human interventions, okay, then is it easy for you to work in this machine learning process? So why is it is important? As I said, as we discussed before, machine learning has applications in all types of industries, right? It's not particular only for computer science or IT department. It can be applied to all industries. Okay. Then the second part is data. Fine. So data is the lifeblood of all business. So data-driven decision is increasing now, correct? So this data-driven decisions increasingly make the difference between keeping up with competition or falling further behind. Machine learning can be the key to unlocking the value of corporate and customer data and enacting decisions that keep a company ahead of the competition. Okay. So as machine learning is a type of AI that enables machines to learn from data and deliver predictive models, it does not depend on any explicit programming, but the data fed into it. So it doesn't rely on any programming techniques, right? It just rely on your data. So it is a complicated process as well, but machine learning is important because it gives enterprise a view of trends in customer behavior and business operational patterns, as well as supports the development of new products. So many of today's leading companies such as Facebook, then Google and the Uber, so they make this machine learning as a central part of their operations. So because of this, machine learning has become a significant competitive differentiator for many companies. So as machine learning continues to increase in importance to business operations and AI becomes more practical in enterprise settings, the machine learning platform will only intensify and won't get reduced. Correct? So any doubts in this? Any questions? Any questions? Okay. So with this, I'm concluding my explanation part. And I'll move on to one of my team member called Vaibhav. He'll be explaining you how to deploy a machine learning in your server, your university server. Okay. So what are the steps you have to follow? Okay. So what's your doubt?
I have a self-driving car.
Self-driving car. Yeah. Okay.
Actually, predicted how to predict the prediction that going to cross the road. Predict that once a person is going to cross the road.
Okay.
Then how will you predict using this machine learning? Is it possible to predict that?
Yes, yes. See that images we will be using for training. Okay. So if you are...
You can predict whether he is going to cross or not. But machine learning, we can predict.
See this, whatever algorithms you are using, there will be data behind that, right? So all the images of that crossings will be there in your training while you are training that algorithms. Okay. So based on that training only, this real part of the car will work. Okay. So it's not like online, it won't go for any suggestion. You will have a previous training on that. Okay. So any other questions? Just feel free to ask. Okay.